You are watching PanBlast Blast Rooms and Waffle Floor Media Recovery Training video. Similar to blast cabinets, blast rooms are large enclosures where operators can perform abrasive blasting without any dust emission into the atmosphere. We can think of them as extremely large blast cabinets, but the operators are working inside the enclosure instead of outside it. Let's go over a typical blast room layout. The blast chamber, item number 1, consists of the entire physical structure enclosing the entire abrasive blast operations and is typically made of structural steel and steel cladding or sandwich panel steel. To protect the steel walls and ceiling and to assist with sound dampening, pliable lining resistant to abrasive blasting such as rubber or polyurethane is used for lining the entire interior surface of the blast chamber. Key elements to consider for any blast chamber design include doors, lighting, ventilation, and work handling. To drive the ventilation of a blast chamber, we require a dust collector, item number 2, to provide suction airflow. Besides providing ventilation airflow, the dust collector will also have filtration capabilities to remove dust, fine abrasive media, and contaminants from the reclaimed air prior to venting to the atmosphere. Next on the list of key components would be the abrasive reclamation system, item number 3, which transports spent abrasives media after blasting to the abrasive recycling and cleaning unit, item number 4, so the good reusable abrasive media can be delivered to the blast equipment, item number 5. Photo number 1 shows a typical blast room installation shielded from the weather elements using standard commercial industrial cladding. Photo number 2 shows another typical blast room installation shielded from the weather elements by being housed within a larger factory facility. In this case, note the additional internal ducting required so that exhaust air can be ducted to outside the factory for venting into the atmosphere. Photo number 3 shows the blast equipment sitting under the abrasive recycling and cleaning unit. Finally, photo number 4 shows the blast operator standing on a work car trolley together with the work piece inside the blast chamber. Note the black rubber lining protecting the walls and ceiling of the blast chamber. Blast chamber sizes. The blast chamber is any enclosure used to house abrasive blasting operations and can vary greatly in size based upon application requirements. A small blast chamber might be only 3 meters by 3 meters, 10 feet by 10 feet for a single blast operator, while an ultra-large chamber might be 40 meters by 40 meters, 130 feet by 130 feet for multiple blast operators. Most blast chambers are customized and sized according to application requirements. For smaller blast room requirements, it is quite common to modify standard 20-foot or 40-foot shipping containers for use as a blast chamber. Modified shipping container. There are many ways to modify a shipping container for blast chamber use. On the left, we have a partial blast chamber layout for the modified shipping container where only a partial section of the shipping container is used as a blast chamber with the rest of the shipping container being used to house the dust collector which provides ventilation to the blast chamber. The abrasive recycling and cleaning system is housed outside the shipping container, but its feed hopper is located within the blast chamber. This allows the blast operator to manually shovel the spent abrasives after blasting into the feed hopper for further recycling and reuse. On the right, we also have a modified shipping container, but it is used in its entirety as a blast chamber with the abrasive reclamation and ventilation system sitting outside at the rear of the shipping container. Customized blast chambers. Because we are building a customized product to suit a particular application, all aspects of the project have to be considered to come up with the best design that meets the customer's requirements and budget constraints and within the physical limitations of the installation site, if any. Key considerations and information required for the project would include maximum dimensions and weight of workpiece, production volume required for the various workpieces, number of blast operators and production shifts, abrasive media type that will be used, physical size and limitations of the installation site, if any, availability of existing work handling equipment, availability and size of compressed air supply, availability and type of electrical supply, integration of blast room system with other new or existing factory equipment, for example, paint room, customer's project budget. The blast chamber structure can be constructed using many different ways. So long as the internal surfaces are protected from the abrasive blast stream and the structural integrity is adequate to meet customer expectations, it does not really matter what construction method is used. On the left, we have a chamber structure made by assembly of standard galvanized steel sheets, while on the right, we have a chamber made by welding of structural elements to be followed by welding of sheets to the structural members to form walls and ceilings. There are multiple door options for blast chambers. Some common ones include sliding, swing, and roller shutter doors. Image number 1 shows a sliding door style blast chamber where the doors open sideways, similar to a building elevator. Image number 2 shows a dual swing door styles blast chamber where the doors open outwards. Finally, image number 3 shows a roller shutter door type design. On the left side of the image, we can see the blast chamber from the outside with the door in the rolled up position. On the right side of the image, we can see the internal view of the blast chamber with the door in the closed rolled down position. The roller shutter door layout has the added advantage of being space-saving since no additional floor area needs to be allocated for door movement. Regardless of the type of door used, a safety door interlocking mechanism is normally installed to ensure that blasting operations cannot be started unless the blast chamber doors are in the fully closed position. This image shows some of the other key features of typical blast chambers. Most, if not all, blast chambers will have some form of ceiling lighting, and for larger wide blast chambers, additional side lighting will improve room illumination greatly. For larger blast rooms, having one or more access doors for operator access into/out of the blast chamber is also common. With smaller blast rooms, operators can simply use the main blast chamber doors for access. With full-floor abrasive media recovery blast rooms, industrial floor grids are also commonly placed on top of the abrasive media recovery system so the operator is able to walk and move around the blast room. With a manual sweep recovery blast chamber, no floor grid is used as a smooth blast chamber floor is needed to facilitate abrasive sweeping and recovery for recycling and reuse. Most blast rooms are ventilated using a cross-draft layout across the length of the blast room, so inlet air ventilation plenums are commonly located towards the front or entry area of the blast room. A common placement location for these inlet air louvers is the blast chamber doors as shown in this photo, or on the roof of the blast chamber nearest the doors. The ventilation dust collector will then be ducted to the opposite end of the room to create the cross-draft laminar airflow necessary to give good visibility to the blast operator. In the case of PanBlast's Waffle pneumatic recovery system, using the 2-in-1 full-floor concentrator system for both blast chamber ventilation and media recovery, we have a downdraft airflow instead of the standard cross-draft airflow. In this situation, the inlet air louvers are spread out evenly across the top of the blast chamber ceiling instead of being located at the front or entry of the blast chamber. Work handling systems can range from sophisticated mechanized trolleys and turntables with articulated work platforms to basic manual fixed platform track and trolley handling depending on client's requirements and project budget. Image number 1 is a typical full-blown work handling solution with articulated work platforms for the operators to traverse across the length, height, and width of the blast chamber. The workpiece itself moves in and out of the blast chamber via the tracks located in the center of the blast chamber. Image number 2 is also a track-style work handling solution which is completely manual and requires the operator to push the trolley and workpiece into the blast chamber. Finally, image number 3 shows an alternate blast room layout to suit inline production operations by having 2 sets of doors, one on each end of the blast chamber. If multiple trolleys are used, abrasive blasting downtime can be minimized because the extra trolley containing the unblasted workpiece can immediately be moved into the blast chamber for immediate blasting after the blasted workpiece on the other trolley is moved out from the opposite end of the blast chamber. Now let's move on to the subject of blast chamber ventilation. For an operator to have adequate visibility during blasting, the blast chamber must be well ventilated. A dust collector should be ducted to the blast chamber at the opposite end of the inlet air plenums to provide the required ventilation air crossflow for removal of airborne dust and fine abrasive media. To size the ventilation dust collector, calculate the cross-sectional area of the blast chamber in square feet. Next, multiply this figure by flow factor of 30 for use with metallic abrasives or flow factor 45 for use with non-metallic abrasives to get the required dust collector's CFM flow rate. Add 10% to the required flow rate if the blast room system will be used by more than one blast operator. It is also important to note that single-use expendable abrasive media such as copper slag, Crushed glass or silica sand should never be used in a blast room system due to dust overloading from the high abrasive breakdown rates. Pan blast standard dust collector sizes include 3000 CFM, 4500 CFM, 5000 CFM, 5500 CFM, 7500 CFM, 9000 CFM, 10,000 CFM, 12,000 CFM, 15,000 CFM, 20,000 CFM, and 30,000 CFM. If an application is in between standard sizes, it's better to upsize to the next available size for improved operator visibility. Similar to blast chambers, dust collectors can also be customized to suit applications that cannot use standard dust collector designs. As an example, let's size a 5-meter wide by 5-meter high by 10-meter long blast room that will be used with glass beads, a non-metallic abrasives. The cross-sectional area will be 5 times 5 equaling 25 square meters or 269 square feet. Multiplying this by 45 gives us 12,109 CFM, so we can select the standard 12,000 CFM unit as the ventilation dust collector for this chamber size. Abrasive reclamation system. Broadly speaking, there are 3 ways for abrasive media to be recovered for recycling and reuse: manual recovery, mechanical recovery, and pneumatic recovery. Let's look at a manual abrasive reclamation system in more detail. For low production volume blast room applications, a manual recovery system is the most economical method. A standard abrasive recycling and cleaning unit such as Pan Blast ProFlow system with a recycling capacity of 3,000 kilograms, 6,600 pounds per hour is ideal for single blast operator use. For dual blast operator applications, the higher capacity UltraFlow system with a recycling capacity of 7,000 kilograms, 15,400 pounds per hour is perfect for the job. For even higher capacity, customized units can be designed and built according to the application requirements. The feed hopper of the abrasive media recycling system is placed inside the blast chamber while the rest of the unit is placed outside. Because the standard feed hopper is designed to mount directly to the boot of the bucket elevator for standalone use, it may need to be modified slightly for use with a blast room, or additional fittings made to couple the blast chamber wall structure and the boot of the bucket elevator together. Alternatively, a replacement customized feed hopper can be made to suit application requirements. With a manual recovery blast room, the blast operator can perform blasting for as long as the blast pot still contains abrasive media, typically around 40 minutes with a standard size 600-pound blast pot such as Pan Blast BP600. This blasting time can be extended slightly to approximately 50 minutes by using a larger volume blast pot such as the BP800. When the blast pot is emptied, blasting operations have to stop and the operator has to sweep and shovel spent abrasive media from the blast room floor into the feed hopper. Once this operation is complete, blasting operations may start again. Depending on the type of abrasive media being used, it might also be necessary to top up the blast pot with some fresh media prior to restarting blasting operations. To make manual abrasive recovery more ergonomically friendly for the blast operator, the abrasive media recycling system can be mounted in a pit such that the top of the feed hopper sits flush or slightly below the level of the blast room floor. By so doing, no shoveling is required of the operator, and the spent abrasive media and dust can simply be swept or compressed air blown directly into the feed hopper. With a pit-mounted recovery system, extra care must be taken to ensure that the pit always stays dry with either no possibility of water entry or adequate provisions made for drainage to always keep the pit dry. Any ingress of water into the abrasive reclamation system will cause equipment failure and loss of production time. A variant of the manual method is via the use of an industrial vacuum recovery system situated outside the blast chamber. Upon completion of blasting, the operator manually vacuums instead of sweeping or shoveling spent abrasives using a pickup wand into a storage silo, which in turn feeds the spent abrasive media into the bucket elevator of the abrasive cleaning and recycling unit. Let's have a closer look at an abrasive recycling and cleaning unit. This video shows Pan Blast ProFlow abrasive media recycling system in action as a standalone unit. Let's now review mechanical abrasives reclamation systems in greater detail. Most mechanical recovery systems are extensions of the manual abrasive reclamation system described in the previous slides. All provide a means by which to reduce the effort of operator sweeping required and mechanically convey the spent abrasive media into the feed hopper or directly into the boot of the bucket elevator. Both illustrations show full-floor mechanical abrasive media reclamation systems. On the left, we have a multiple screw conveyor layout with individual screw conveyors laid along the length of the blast chamber feeding into a central screw conveyor, which in turn feeds directly into the boot of the bucket elevator. On the right, we have multiple rows of individual belt scrapers laid along the length of the blast chamber floor, feeding into a central belt scraper which then feeds directly into the boot of the bucket elevator. While both the illustrations show full-floor mechanical recovery with multiple feeds into the central screw conveyor or belt scraper, the individual screw conveyors or belt scrapers can be eliminated or reduced for a partial floor recovery system. For a partial floor recovery system, the blast operator has to sweep spent abrasives from the floor of the blast chamber to the nearest screw conveyor or belt scraper. In both cases, PanBlast's standard ProFlow and UltraFlow abrasive recycling system can be used for abrasive media cleaning by simply removing the standard supply feed hopper and having either the central screw conveyor or central belt scraper feed directly into the boot of the bucket elevator. Besides the civil works construction costs and pit drainage considerations, another key consideration for mechanical media recovery systems is wear and tear during use. Because of the abrasive nature of spent media being recovered, both screw conveyor and scraper systems are under heavy abrading action during use, so the use of wear-resistant materials in the construction of such systems is absolutely critical to keep equipment downtime to a minimum. The pneumatic abrasive reclamation system is probably the ultimate media recovery solution for any blast room setup. Unlike mechanical recovery systems, pneumatic systems use vacuum suction to transport spent abrasive media from the blast room floor to the airwash reclaimer where dust and fines are removed so reusable media can be recycled and fed back to the blast pot. Because there are no moving parts in the entire system to break down or wear out, maintenance requirements are minimized with virtually no operational downtime. PanBlast's Waffle floor system is a modular pneumatic vacuum recovery solution that can be fitted to any blast room project. In place of mechanical screw conveyors or belt scrapers, Waffle floor modules are used. Each module is fabricated from mild steel plate and consists of a folded tray which forms the bottom of the waffle as well as the sides, with a folded inverted V section which forms the center recovery duct. High-velocity air is drawn through the center duct and down the length of the waffle module. Spent abrasives and debris falling into individual hoppers are pneumatically conveyed down the center duct to the adjustable cyclonic reclaimer assembly. There is also a change in the abrasive recycling and cleaning unit for this system. In place of a mechanical bucket elevator and airwash separator such as the ProFlow or UltraFlow, the adjustable cyclonic reclaimer unit performs the work of separating dust and fines from reusable abrasive media. Air is drawn through an adjustable gap created between a fixed outer cone and an adjustable inner cone, and as abrasive media falls past the gap, the dust and fines are drawn away from the usable abrasive media and conveyed through to the reverse pulse jet cartridge dust collection system. Adjusting the size of the gap between the fixed and adjustable cones will vary the intensity of the abrasive media separation required. Having the flexibility of full adjustment allows for variance in abrasive media types and sizes that can be used with the Waffle floor recovery system. The reverse pulse jet dust collection system is outfitted with high-efficiency filter cartridges which capture the fines and dust generated by the abrasive blasting process, allowing only clean air to be discharged to the atmosphere. Let's have a closer look at the Waffle floor abrasive media recovery system in action. Let's go over the key features of the Waffle floor recovery system. No moving parts. Other than the rotating action of the fan impeller fitted on the dust collection system, there are no moving parts in the entire system, minimizing maintenance requirements and virtually eliminating operational downtime. High floor loadings. The triangulated construction of the Waffle module makes it extremely strong, allowing trolley tracks and work cars, etc. to operate directly on top of the Waffle modules. No special foundations. The Waffle modules can be located directly on top of any flat level surface or can be recessed flush with an existing floor, providing a substantial cost saving in comparison to mechanical recovery systems requiring extensive excavation costs. Any abrasive media type. All types of abrasive media can be used with the Waffle floor recovery system, including metallic grits, garnet, glass bead, aluminum oxide, and plastic media. Wide range of configurations. The Waffle floor recovery system can be adapted to suit any blast room size, providing either full floor or partial abrasive media recovery. Ventilating air. In small blast room applications, the recovery air can also ventilate the blast room and clear the airborne dust without the need for further capital outlay for a ventilation dust collection system. Let's review layout options for the Waffle floor recovery modules. The Waffle floor modules are available in three basic sizes: 600 mm, 24 inches wide, 1000 mm, 39 inches wide, 1500 mm, 59 inches wide. The maximum recommended lengths of the modules are as follows: 600 mm, maximum 6 meters, 19.7 feet long; 1000 mm, maximum 20 meters, 65.6 feet long; 1500 mm, maximum 30 meters, 98.4 feet long. Excluding the typical 25 mm depth of the pedestrian grid sitting on top of the floor, depth of the various modules are 600 mm, 150 mm, 5.9 inches deep; 1000 mm, 250 mm, 9.8 inches deep; 1500 mm, 375 mm, 14.7 inches deep. The Waffle floor modules can either be placed flat on the factory floor, in which case the blast chamber floor is elevated by the depth of the Waffle module selected, so a ramp or elevated work handling track needs to be built at the entry of the blast chamber. To get a flush blast room floor, shallow pits can be created so the Waffle modules and pedestrian grid can be fitted inside the pits such that the top of the pedestrian grid is flush with the surrounding factory floor. The Waffle floor modules can be connected to the cyclonic reclaimer assembly by either fabricated ducting or heavy-duty suction hose. Due to high wear rates on some installations with fabricated ducting and flexibility during installation at the job site, the first preference is to use transitions and heavy-duty suction hoses. The most common Waffle floor layouts are single, twin, or triple module systems. These are usually located down the sidewalls of the blast rooms for optimum abrasive media collection, but they can also run across the blast room width if required. Systems with requirements for trolley and tracks inside of the blast room generally require 3 Waffle modules, with one module located between the tracks. This is to cater for any abrasive media left between the tracks, which can be difficult to recover and will be classed as a dead area if no method of media recovery is available. The ideal blast room will have a full floor Waffle recovery layout to completely eliminate downtime for spent abrasive media and debris sweeping. The final step is to select a suitable reclaimer size to suit the Waffle floor module layout selected. The approximate recovery flow rate for each width of Waffle module are 600 mm wide, 60 CFM per 300 mm length; 1000 mm wide, 60 CFM per 500 mm length; 1500 mm wide, 60 CFM per 750 mm length. For multiple Waffle modules, simply add up the lengths to calculate the total required for CFM flow rate of the abrasive reclaimer. As an example, let's say we have a twin Waffle layout for a 10 mm long blast room using 1000 mm wide Waffle modules. This equates to a total Waffle module length of 2 times 10 or 20 meters. Dividing 20 meters by 0.5 meters and multiplying by 60 gives us 2400 CFM flow rate as the correct reclaimer size. Note that these figures are approximate and may vary with the type and size of abrasive media being used in the blast room. If in doubt, consult a Pan Blast technical professional to get assistance with equipment sizing. The Waffle Floor Recovery System can operate successfully on all common types of abrasive media, including metallic grits, both steel grit and chilled iron grit, garnet, glass beads, aluminum oxide, plastic media, organics, nutshell, corncob, etc., steel shot, rarely used in blast rooms. The most cost-effective abrasive for a recycling system in a blast room is steel grit, as the number of cycles through the system is far greater compared to other abrasives such as garnet. Garnet will generate much more dust than other abrasives. This can often lead to the dust collection system being upgraded to enable the system to cope with the higher dust loadings. Finally, let's move on to the last element required of any blast room layout, the blast equipment itself. All blast room systems should be fitted with one or more automatic blast pots with remote controls sized based on the size of the blast room and required equipment response time. Standard pneumatic control pots with manual adjustment abrasive metering valves such as the FINA 2 will be more economical but will have some delayed response time when compared with electrically controlled pots with pressure hold metering valves such as the Corsa 2. However, unlike open blasting, there will be no abrasive wastage from abrasive surge on startup since the media can be recovered and recycled in the blast room environment. Recommended pot sizes are the BP600, MB600, and BP800 series with 40 to 50 minutes of continuous blasting times. MB pot series have steep angle cones for use with media with high angle of repose such as plastic abrasives and can also be fitted with special diaphragm valves for low-pressure blasting. For full-floor waffle recovery systems, the continuous blast CB800 pot series will provide non-stop blasting for as long as the blast operator can physically keep up the blasting work without resting. Photo number 1 shows the location of blast equipment in a typical blast room setup underneath the abrasive reclaimer feed spouts and located between the blast chamber and ventilation dust collector. Photo number 2, an enlarged view of the blast equipment area. In this case, we have two BP600 series blast pots being used in this blast room installation. Photo number 3 shows the blast operator inside the blast room with the workpiece properly masked and ready for abrasive blasting. Finally, photo number 4 shows the workpiece after blasting using glass beads as the abrasive media. Things you should know. Key components of blast room systems. Key considerations and information required for blast room projects. Common blast chamber designs and layout. Blast chamber ventilation. Abrasive reclamation, cleaning and recycling options. Waffle floor pneumatic recovery layout and sizing. Blast equipment options. This brings us to the end of this video. We hope you've enjoyed viewing it, and for those of you pursuing silver or gold level certifications, we wish you the best of luck for the online test.